Hello, welcome to this video. We're going to be talking about correlation. This is the last video in this group of videos, the introduction to econometrics class. I'm going to be talking about the different type of correlation and how to apply that using Excel. But let's go ahead and come up with a definition to what is correlation. I made a link to a really powerful website that you might be able to use it frequently, whether it's in your term paper or just to find out additional definition to something that you're looking for. Correlation, we know it's a statistical measure that indicates the extent to which two or more variables fluctuate together. So positive correlation shows you that two variables either increasing or decreasing in parallel. So the idea, it's not because they are positive correlation, that's mean they are both increasing or both decreasing. As long as they are increasing or decreasing in parallel, there is a positive correlation. On the other hand, negative correlation always indicate to which one variable increases, of course the other one is going to decrease as a result. The fluctuation by no means means causation, and that's we need to be able to always keep that in the back of our head. When we talk about correlation, it does not imply causation. We talk about, for example, the number of the hours that a child watch a TV. It was correlated to the fact that there is a bully behavior or bullying behavior on that child. So the media coverage came up with that specification that those two could be causing each other, but the reality might not at all have anything to do with each other from a causation point of view. However, maybe they are related, or correlated is a better word. Maybe some other things like the absence of their parents and the discipline that goes along with their bringing a child or raising a child up. It's not really a simple task. So it's really going to be looked at clearly and see what other variable that might also cause that type of behavior. So that's a very quick example. Anyway, let's take a look at the data here. And first, I want you to realize this is an image I got from Google. It's very clear that the positive correlation, usually it goes through this direction, and also negative direct correlation, very similar to the supply and price, where one of them is increased, the other increases. Typically, negative correlation, one decreases, the other increases, so it's an inverse relationship. And no correlation, there is nothing you could really make out of this number of points that they are scattered all over the places. So I did actually a set of data with Excel, because we're going to focus on how to use Excel for most of the function that we wanted to show you in this class, because Excel is a very available, as I said before, and I will say that also in the future to all of us, as readily as it gets. So if I take here the correlation for X and Y, if you look at the data here, 0, 2, 10, 12, 4, 6, 8, 10, this is increases, there is always an increase in Y. There is a function, it's called correlate, see here, and you could go ahead and do the first array, which is in this case this one here. We call it array, I call it set or range, it doesn't matter. And notice this is a perfect correlation because it's 1. So if I take these two and go ahead and insert a chart with two piece of data, I could go ahead and also get that to show me the actual value. Here we go. Where is it? Yeah, we could go ahead and show you the actual value on the chart. You notice that one increases, the other increases along with it. So they are parallel to each other. This is the 0 is parallel to 2, 10 is parallel to 12, 4 is parallel to 6, 8 is parallel to 10, and 12 is parallel to 14. So this is very easily done in Excel, as you notice, and this is an example of a perfect correlation. The other here, if you notice here, 0 is going to 2, so there is an increase. If we take in here 10, it's minus 8, 2, 0, 12, minus 10, 6, minus 4. And if we do that, look at the chart that we're going to get from using the line chart with 2, Notice here it's basically, they're opposing to each other here, so it is going to be a negative correlation, but it's going to be a full correlation with minus 1. Let's make sure that we can get that minus 1. If I do here correlate, and notice this is going to be this range and followed by this range, and we're going to go ahead and get completely negative correlation, which is minus 1. So there is negative correlation, there is absolute, not absolute, basically it's perfect positive correlation, perfect negative correlation. Minus 1 is the biggest values that you're going to get in relation to correlation. Of course, if it's 0.9, 0.8, the degrees start to decline. However, 1 is the maximum value we get. Let's take a look at this sheet and see what we're going to do with a 3 variable instead of 2. Instead of using the correlate function to take A and B individually, then we could take B and C individually, then we could take A and B individually. There's a lot of work associated with all that. So what I'm going to do is to go ahead and use the data analysis that already been added through the add-in one more time. If I don't have it, I'll go to the option, go to add-in and click on go, and notice I have already added the analysis tool pack. Later we're going to add the solver add-in as well. So I already have it, it's right here in the data. If I click on it, I'm going to go ahead and look for the correlation and see where it is in order to go ahead and get that analysis being applied. The input is clearly all of them. I'm going to go ahead and do that. The data is grouped by columns, not by rows. I wanted to have the label because ABC is the label. And I'm going to go ahead and put the output range directly right here. So it's not going to be far away from me. And also it's not going to be into a new workbook. So I'm going to go ahead and say OK and show me what we got here. So what did we get? First of all, I could tell you that A and B have no correlation whatsoever. It's very tiny value, it's 0.19. Between A and C, they have really strong correlation, as you notice, between the A and C. B and C, they have extremely small correlation, even smaller than A and B. So how do we do this in order to prove that graphically? I'm going to go ahead and insert, go to the three values. First of all, I'm going to go ahead and select all those, and let's go ahead and do those here directly instead of trying to figure that out on our own. Selection is very helpful, and notice if I could go ahead and even change the I like this one here, but it's too much for our view here, but I could go ahead and change that into something like this where it shows the actual data. You don't want to clutter your chart. However, we're not concerned too much with the cluttering as much as we're concerned with understanding how is the correlation makes sense for us. Notice here when we talk about A, B, and C, the correlation between A and B, where is this? That A and C is very, if you notice here, I could show you this one here, and this one is very good. However, A and B, if you notice it here, A and B is very little of it. Notice also C and B are the red one, and the C is there. They're actually not corresponding to each other as well. That B is kind of flat. You know, it's very flat in here. So again, correlation is an indication of there might be causation, but it doesn't by any means indicate that these two variables cause each other. But it indicates something like this: that relation between A and B. It indicates that they are very, very related or correlated to each other. Between B and C, there is very little correlation, as you notice, and of course between A and B, A is the blue and B is the red. There is not as much correlation as you think. And here we go. This is the end of this video, and I hope you learned something through this. We're going to continue with other videos for the next set of topics we're going to be discussing. Thank you very much. Here's Dr. Hijazi. I wish you a happy day. Take care.